I'm Yusuke Endoh. This title, Esoteric Obfuscated Artistic Programming in Ruby, is the same as my RubyConf talk of the last year. But I'll show you almost different set of programs than RubyConf. So I'd like to rename this site in British style. And now for something completely different in Ruby. As this title, in this talk, I will show you some completely different programs than you have ever seen. Okay, first, let me introduce myself. I'm Yusuke Endoh. My Twitter account is Mametta. M-A-M-E pronounces mame in Japanese, not mame. Mame means, in Japanese, peas or beans. Many Japanese friends call me Mame-san, which literally corresponds to Mr. Bean. Okay, anyway, I'm MRI committer, Matsuruby interpreter committer, since 2008. And I was the release manager for Ruby 2.0. And I have implemented some features, including coverage measurement feature and keyword arguments. My recent achievement includes improvement of coverage measurement feature that now supports branch coverage. And thank you. And last year, I joined Cookpad as a full-time Ruby committer. So my current job is to develop Ruby. Cookpad now employs 2 full-time committers. Full-time Ruby committers, Koichi Sasada and me. And I'm now here thanks to Cookpad for sending me to Bristol and Bath. I believe that everyone knows Cookpad. It is the gold sponsor of Bath RubyConf. But for the case, let me introduce Cookpad. Cookpad is one of the world's largest recipe sharing platform service. You can publish your original cooking recipe and find recipes of other users. There are 90 million monthly average users in the world in total. Currently, Cookpad supports 22 languages, and the service is running at 68 countries. This service is still growing to aim to be number 1 in 100 countries. To maintain this service, we need many great engineers. So we are hiring. I'm working at Japan, but Cookpad global headquarters is here in Bristol. So if you are interested, go to the Cookpad booth as soon as possible. Okay, today's topic, as I said, this talk is about unusual, completely different Ruby programs. And you know, Ruby is very flexible language. Ruby is much more flexible than you think. By exploiting this flexibility, I show Ruby can do anything. Ruby programming is fun, not only in normal sense, but also abnormal sense. I'll talk about 2 themes. One is Ruby with limited letters. I'll show, in this section, I'll show 2 Ruby programs that use very limited set of letters. The other is funny self-descriptive Ruby programs. I'll show some self-reproducing programs called Quines, or Quines programs with some tricks. Then enter the first section, Ruby with limited letters. Okay, the first example is this. This is a program written in Ruby, you know. Can you read this? Okay, let's run. This is a program, and run it. Okay, hello and Bristol Ruby. It works. So this is a Hello World program written in Ruby by using only numbers. In this case, I show hello world as just as an example, but this is not limited. We can encode any Ruby programs into only numbers. Okay, I explain it the internal briefly. This program uses two techniques, Gödel numbering and Ruby's black magic. I will explain in turn. Gödel numbering is a technique to encode any given number, any given string to a natural number. In theory, Gödel numbering accepts a string byte array, n1, n2, n3, blah, blah, and outputs a number that is calculated this expression to the power of n1 times 3 to the power of n2 times blah, blah. And these numbers are all primes. So we can decode this number to original byte array by using prime factorization. This naive approach works, but the resulting number will be very huge. So actually, this gem uses more practical and easier approach that is specialized to ASCII code. Anyway, by using this numbering, we can encode and decode any Ruby code as one number. And there is another problem. The code has a number, but it is just written. This number is just written. It is not assigned any variable, and it is not passed to any methods. So there looks, okay. So there is no way to get the reference to the number. But we can get the number by using Ruby's black magic. Can you guess the answer? So my answer is object space each object. Honestly, I don't know if this is guaranteed behavior by Ruby's specification, but it may be optimized in future. But it currently works, actually. Anyway, by using this method, this program enumerates all big integers that are allocated in Ruby interpreter heap, finds the number that is encoded from Ruby code, and finally executes the decoded code by using eval method. So please read the library code in detail. It is just 32 lines. Incidentally, you can install this library by using gem install as usual. Note that the library name is 123456789, but the gem name includes underscore at the last. This was needed because Ruby gems required at least one letter but number. That's unfortunate. Anyway. Okay, the next. This is Hello World 2. Okay, to confirm. This is the program, and run it. Oops. Run it. Okay, hello. Bash and Bristol Ruby. Oops. So this is just Hello World program written using only underscores and spaces. Again, this is not limited to Hello World. You can write any favorite Ruby code in only underscores. The internal is almost the same as number variant. It encodes a code to a number. Instead of representing the number as is, this program encodes the number to underscores in base 6. This assigns each digit n to underscores whose length is n plus 1. And these underscores are method calls, so the library can easily hook them and decode and execute the original code. You may wonder why chose base 6. This is because base 6 minimizes the expected code length. This this expression represents expected or average length of encoded code. B equals 6 minimizes this expression. Of course, you can install this library by using gem. The gem name is just one letter, underscore. Okay, trait, please. Okay, I conclude the first section. I showed that Ruby is very strong against letter limitation, restriction. We can write Ruby programs by using only keypads, or even just 2 keys, underscores and space keys. If you want to see other example, please check the video of my RubyConf talk. I showed Hello World only symbols and only alphabets. Okay, go to the next section. Funny self-descriptive Ruby programs. This is the first example. What do you think what this is? This looks 1. Okay, let's run. This is the code, and run it. Okay, 2. The result is a valid Ruby code, so we can run this. By using pipe run it, fizz, F-I-Z-Z. And repeating this process for buzz, fizz, 7, 8, fizz, buzz, 11, 12, fizz, 13, 14, and fizz buzz. Okay. Great. Okay, so this is a self-descriptive fizz buzz I call. Each produces executable Ruby code that produces executable Ruby code that produces executable Ruby code, blah, blah. And each code is shaped as fizz buzz numbers. This program does these processes. First, it reconstructs its source code as a string. This process is so-called Quines. And then it reshapes the string as the next fizz buzz number. For the sake, this program contains compressed font date and fizz buzz algorithm, and shaping it itself to the number of fizz buzz or fizz or buzz or fizz buzz. Finally, outputs the shaped string. We need to write this code as an ASCII-shaped executable Ruby code. I explain some key techniques in turn. First, Quines. Quines is a program that outputs itself. It is relatively easy to write a simple Quines in Ruby, like this. This code first reconstructs itself as a string by using, in this case, string concatenation and inspect method, in this case. And then it just prints the result. We can make this Quines funny by adding additional step between first step and second step. In this case, I added reshaping to fizz buzz numbers. For the reshaping process, this program contains fonted, as I said. This is the original uncompressed data. This is not compressed yet. Embedding this as is to the code makes the program very big, so it is not so cool. So I use some kind of compression to embed. First, I represented the data with 0 and 1, and then interpret each line as a binary number. These 5 numbers takes just 50 bytes, so much shorter than the original data. Furthermore, we can shorten them by using base 36 by using 2s method. Okay, finally, I explain the trick of executable ASCII art. It is very easy to shape a Ruby code as you like. First, write your code without space and backslashes. Then wrap it with eval paren, %w, paren, and close paren, full stop join, close paren. As you know, %w literal generates an array of strings, and array join method merges them to one string. So this is an idiom to remove all spaces from the content. So finally, we can insert spaces into your code and shape as you like. For example, like this square. When you run this square, you will see hello world. This technique highly depends on Ruby's rich % notation. Okay, from now, I show some funny coins I created. This is called coin relay. Coin relay is a Ruby code that generates Rust code, that generates Scala code, blah, 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 that generates Rex code, and finally, that generates the original Ruby code. So this is an Ouroboros coin that requires 128 languages in turn. This is a list of the languages. Ruby, Rust, Scala, Scheme, Scilab, Sales, and Rex and Ruby. Note that it is in alphabetical order. Okay, this coin takes a few minutes to execute, so I don't demonstrate this. But you can see the demonstration in Travis CI. Oops. Okay. And this is the first step. It executes Ruby command to execute qr.rb to generate the next Rust code, qr.rs. And the second step, Rust C compiles r.rs, qr.rs, and executes the executable generates the next Scala code, and blah, 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 blah. Okay, this is final step. Rex interpreter executes qr.rex code and generates qr2.rb. And the final step, it compares the original code qr.rb and the generated qr2.rb, and these files are identical, so it works. Okay. Its internals is very easy in theory. This is a coin written in Ruby, and this is a hello world written in Python. We can write Ruby and Python's two language coin relay, Ouroboros coin, by combining them like this. This code first reconstructs itself as a string and wrap it by Python's hello world, and finally prints it. This is two-language coin. Oops. Okay, so theoretically, we can get 128 language coin relay by repeating this combining process 127 times. But this naive approach results in very huge intermediate code because of the many fragile interpreters. So some fails to run such big code. So it uses many tricks, including compression algorithm and on-time code generation and blah blah. So please see the source code in detail. Okay, next. This is a column-shaped object, real object. By inspection, you will see Ruby code inscribed. When this Ruby code is executed, you will get 3D model data of this column. By sending the data to 3D printer, you can get this column. You can buy this column at Shapeways, about $65. Okay, and this is the internal, and this program is also just a Quine, but instead of just printing its code, it generates 3D model data that embeds its code. For this 3D model generation, this program contains embedded true type like font data and Bezier curve renderer. After triangulating the polygons of each two-dimensional font glyph, it assembles them to 3D model data. Interestingly, we need to make this code shorter because of 3D printing fee. So the shorter code and the shorter object, the cheaper. So this object is bigger, the 3D printing fee will become more expensive. For the sake, I avoided some complex glyph letters like 3 and 8 and Z. By omitting them, by avoiding these letters, we can remove their glyph data from font data. So this middle part will be shorter. And I said in the first section, Ruby is so strong against letter limitation, so this was possible. Okay, next, I call 15 puzzle. This is the pan of 15 puzzle and Quine. This is a Quine. This Quine is interactive. I demonstrate it. Okay, so ちょっとビッグですね。Okay, use this. Okay, this is a code, and just running it produces itself. So this is a Quine, actually. And by passing D as an argument, watch this panel, this 13 panel. This 13 panel is moved to down. Do you understand? Okay, of course, the result is executable because, so we can run it by using pipe, like this. Watch this panel, 3. Okay, move to down. So we can move the panels. And this process is running, so to make this process easy, I wrote a simple wrapper tool. Okay. I can move it by VIM keyboard layout. So I think it is, please wait, I'm solving this. One, two, three, four. 5, 6, 7, 8. Okay. Yeah. Thank you. So when completed, this command shows clear message. Okay, this is tic-tac-toe. This is not only interactive, but also containing AI, artificial intelligence. Too big, sorry. Okay, this is the code, and each cell is assigned a number, and 1, 2, 3, 4, 5, 6, 7, 8, 9. By passing the number, I can put, I can put O. And in the next passing no argument, AI puts cross. And I put 2, and cell 2. Yeah, and the next AI puts, it preserves my and so I can put 7. Yeah, and AI puts. Okay, so this we cannot win. We cannot beat this AI, as you know. Okay, the next. This is a media involving Quine called King and Kif. King is a ping image that contains Ruby code that produces this ping image. The Kif is a GIF variant. Okay, this is the last Quine in this talk. I call reprogram Quine. Let's run. Oops. This is a program, and run it. Oops. Okay. So this works just as normal Quine, but okay. Consider. Imagine one letter is removed from the word. Consider, in this case, we lose A, small a, for example. Remove all recurrence of A from the code, like this. This code is no longer a square, so we can see actually lost some characters. And save this as broken RB. Broken RB and run the broken script. It works. Surprisingly, it works without exception. This result is in fact identical to broken RB. So, reprogram is a word game to write paragraph in which a particular letter is avoided. Reprogram Quine is a Quine that works even if any one letter is completely removed. In this case, we removed A, but we can remove any one character instead of A. Okay, I believe, sorry, skip the internal. There's no time. Okay, that's all. My English is so fast, so you might not understand my talk. If you want to understand or see my other programs, please buy my book, The World of Obfuscated Esoteric Artistic Programming. It contains about 40 programs like this talk. Unfortunately, it is written in Esoteric Japanese. Okay. Related work, you may have heard IOCC's Internet Obfuscated C Code Contest. This annual contest is for hard to read C programs. About 10 programs are awarded each year. And there are similar contests for Ruby named Trick, a Transcendental Ruby Imbroglio contest for Ruby Kaigi. Ruby Kaigi is Japanese RubyConf. I'm a member of judges team of Trick. We have held Quick twice, 2013 and 2015. I plan to hold the final Trick contest for RubyKai 2018 in this year. So please, if we have interest, please submit your Esoteric Ruby code to us. And see this GitHub repository in more information such as rules, guidelines, and how to submit, and previous winners. In this, the deadline is the end of this month, so you still have a week to enter. Okay, I conclude this. I'd like to say Ruby is very, very rich, flexible, and great language. You can write Ruby with broken keyboards. You can write artistic and super robust Quines. And anyway, I wanted to demonstrate in this talk is Ruby programming is fun. This is true, even if practicality. No and anyway, but if you are interested in only practical programming, please join QuickPath. There are many practical tasks which must address in Ruby. Okay. Okay, one more thing. As one more example, I created new program for Bass Ruby conference. Let me show this. This Quine somewhat depends on hardware, so I created a movie. The program, this is a program, and run it. This takes about 2 minutes. This Quine, this is a Quine, but each first prints a code that does nothing. This program plays music. This is not just BGM. This program contains music score data of Susan's the Liberty Bell and Elgar's Land of Hope and Glory. This program generates sound wave based on the scores and send it the generated sound wave to sound driver. Escape sequence to move cursor. Okay, that's all. Thank you.